All right, in our last little tiny video before the exam, section 11.4, quadratic in form. This is a tricky section, but it doesn't have to be. I got a couple of tricks for you. Let's just start right off with example 1 here. Factor and solve x squared plus 2x minus 15 equals 0. Pretty straightforward idea. You're just looking for numbers that multiply to be this and do this to be this. Numbers that multiply to be 15 and subtract to be 2. That'd be 5 and 3. 5 is the larger one. It needs to be positive. The small one is negative, so they multiply to be that negative 15. And then x plus 5 equals 0, x minus 3 equals 0. Solve them each. You have negative 5 and 3. Works beautifully. That's a quadratic equation. What if it's quadratic looking? You can kind of get an idea that this is a quadratic function by looking at it. For instance, this thing right here, when squared, becomes this. And it doesn't exist here. There's nothing here, there's something here, and when you square this, you get this. Do you notice that there's nothing here, there's something here, and when you square this, you get this. When you square x squared, you get x to the fourth. So what we're going to do is we're going to use this thing called a u substitution. I think math people say u substitution because you get to do the substituting. I don't know. But anyway, we're going to let u equal x squared. So this x to the fourth, which is x squared squared, and this 2x squared stays the same, minus 15. We can replace the x squared with a u. So really we're factoring u squared plus 2u minus 15. This doesn't look nearly as ugly. We just factor it, set each factor equal to 0, and solve. But then you've got to resubstitute the x squared back into place for those u values. So instead of u equals negative 5, it's really x squared equals negative 5. And instead of u equaling 3, it's x squared equals 3. Well, then just solve them. Square root both sides. Plus or minus I squared to 5, plus or minus square root of 3. Okay, so this idea right here, do you still, again, recognize it? And I don't think you can see my face, sorry, which is probably okay. Do you recognize it again? There's nothing here, but there's something here, and when you square the square root of x, you get x. This is quadratic in form. So I'm going to let u equal the square root of x. And this becomes u squared plus 2u minus 15 equals 0, and you just solve it like before. But again, in the very end, you're going to resubstitute back, so you know that blah, 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 what u equals negative 5, u equals 3. If u equals negative 5, that means the square root of x equals negative 5. Square both sides, you get x equals 25. You also get u equals 3. That means the square root of x equals 3. Square both sides, x equals 9. And those are your two values. Check them, make sure they both work. They might not. You might get some extraneous solutions to cross them out, but that's the idea of setting up the quadratic in form. The last one right here, nothing here, this thing here. When you square it, you get 2/3. So I'm going to set this up as u is the same as x to the 1/3. So this becomes u squared plus 2u minus 15 equals 0. Solve, you get u equals negative 5 and u equals 3. Resubstitute back in, x to the 1/3 equals negative 5, x to the 1/3 equals 3. Cube both sides, x equals negative 125. Cube both sides, x equals 27. Check those two and make sure they work in the original equation, and you are good to go. So that's the idea of quadratic in form. Email me with questions.